Hi, my name is Meghan Page, and I'm an associate professor of philosophy at Loyola University, Maryland, and I'm a visiting fellow here at the center. My research concerns the intersection of historical science and geoscience. So in particular, I'm interested in questions of how learning about the past helps us understand the current climate crisis. I feel like the intersection here is really important, both from a practical standpoint. So just in thinking about how we understand the way climate works, and how we understand sort of the crisis that we're in, a lot of that is learning about and being able to extract how humans as a species are contributing to changes in the climate. Well, to understand how we're affecting the climate, we first need this kind of baseline understanding of how the climate works, right? And we know that the climate varies in a lot of ways over, short periods. So we get climate, you see seasonal variation. You know that the climate changes according to the seasons. And we also know that the climate changes on larger cycles, sometimes of like 7 to 10 years. And we also know that the climate changes on larger cycles, sometimes of like 100 to 1,000,000 years, or something, not 1,000,000 years. But there are these larger variations in climate cycles. But we can't study those, right? Because of our time cycles. We're these short humans that are here for a short time span. So to observe these larger patterns of climate and be able to use them as a background to kind of figure out how are we now affecting those kind of natural cycles, we have to turn to historical science. Historical science is a way of using traces and markers that we find out in nature to reconstruct the story of the past. Like what happened on Earth, what happened to Earth's climate over these large timescales that we don't have recorded observations of, right? What happened to the climate? What was the Earth like 250 million years ago before humans ever came to exist? Those are the kind of questions that you're trying to understand when you're doing historical geoscience. And like I said, those questions are super important practically because they give us this kind of baseline for understanding what are we actually doing to the Earth? What is our lifestyle? What is civilization? How is it changing and impacting the climate? And how much of the change that we observe is human induced and how much of it comes from natural variability? And also, like, what kind of natural variations can we expect that are going to amplify or dampen sort of human contributions to climate change? So that's the kind of practical interest in my project. But I also think that there's a lot of interesting stuff happening here philosophically. And that's because when we think about historical science, we're pushed into this bigger framework for thinking about science, and it pushes on a lot of the boundaries of science and the boundaries of philosophy of science. So what do I mean by that? Well, some of my earlier work, I explored these questions about laws and the stability of laws and how historical science plays into that. So when we think about, laws and regularities in science, a big part of what we do in science is we go out and we see what happens and we write it down and we keep writing it down, and then we notice these stable patterns, right? And so when we feel like we've tracked on to some kind of stable pattern in nature, we think of that as a regularity, or if it seems really stable, we might think of it as a kind of law. But we're always observing in these limited contexts, right? So for example, you wouldn't trust an observation that, like, if you observe some regularity, but you only ever observed it in Pittsburgh, something like, it's always gray in May. You wouldn't want to think that that's a total regularity that, extends to the whole universe, that everywhere it's gray in May, right? We think of that as kind of this local regularity. Well, how do we know if a regularity is stable? You have to sort of keep observing in broader and broader contexts. And that's what we do in science. We try to observe gravity all over the Earth, so on and so forth, and get this sort of general story about how does it work. But what we don't always know how to account for is sort of the context of time, right? So just in the same way that we have these spatially dependent contexts where we're kind of studying the Earth, we always also have temporal context in which we study the Earth, right? Like all of our observations are falling into this time slice of Earth's history, which is a very small piece of the story of the Earth, just like Pittsburgh is one location on the Earth. So just like we don't want all of our observations about what the Earth is like to come from Pittsburgh, we also don't want all of our observations about what the climate is like to come from right now. Because the kind of regularities that we observe right now might be dependent on that kind of time slice we're in. We need this bigger picture. So how does that work? Well, again, asking these questions really pushes on traditional issues in the philosophy of science of like, how do we do scientific inference? How do we gather evidence? How do we get measurements? So that's been a big part of my project here at the center, has been thinking about proxy measurements. So in kind of standard accounts of measurements, we put a lot of focus on, the instruments that we use and the models that we have of a measurement process. So Hasek Chang was a philosopher that has this famous book. It's really great, called Inventing Temperature, and it talks about how do we even get to quantities like temperature from observation. And we do it by constructing instruments and having models of those instruments and sort of having these like repeated tests of these instruments until we can get them all to agree and say the same thing. Well, it's tricky because what do we do when we want to measure, we want to get measurements or data about the temperature like 100,000 years ago, right? There were no instruments, we don't have any records, we can't really apply models to these measurements. What do? Well, what you actually do is you find tracers, like we have tree rings or we have these isotope records in ice cores, and you sort of try to generate some relationship between those and temperature to extract something like a measurement. But it's not exactly the same. And the way in which it's different, which is what I've been spelling out in my project here, tells us a lot about how to think about measurement more generally, how we think about measurement now. And it also tells us something about how we can evaluate this really important science that helps us learn about the past and helps us understand the current climate situation that we're in. So yeah, that's sort of broadly my project, and thanks for letting me talk about it.